welcome to lesson 80. This is called prime and composite numbers. Now, the important thing to remember for this lesson that we have already previously learned is what factors are. Remember that factors are numbers that are being multiplied together. So whenever we find the factors of, let's say, 10, I want to find all the numbers that I can possibly multiply by each other to equal 10, such as 1, 2, 5, and 10. All of those numbers, 1 times 10 and 2 times 5, all equal 10. Those would be my factors. Now, that helps us when giving these numbers actual names such as prime or composite. Prime numbers are numbers with exactly 2 factors. I underlined the word exactly for a reason. They have to have only 2 factors. They can't have 1 factor and they can't have 3 factors. They have to have exactly 2. So I want you to go ahead and have these definitions written down. We also have composite numbers. Composite numbers are numbers with more than 2 factors. So if it's not a prime number and has more than 2 factors, it is definitely going to be a composite number. So we have prime numbers, we have composite numbers. So right here I went ahead and made a little chart that I would like you to also copy down of all the different numbers listing their factors. I only have numbers 1 through 6. Your book actually has numbers 1 through 10, but I did only numbers 1 through 6 for space reasons. And then also the types that they are. Now notice here, 1 is the only number that is neither prime nor composite. It only has 1 factor, which is itself. So 1 is the only number that is not prime and it is not composite because it has 1 factor. So it doesn't fit under exactly 2 factors and it does not have more than 2 factors. Then we have 2. I have factors 1 and 2 because 1 times 2 is 2. It has exactly 2 factors, so it is prime. 3 also has only 2 factors, 1 and the number itself, which means it is prime. 4 is our first even number, that is composite. And I can have 1, 2, and 4 because 1 times 4 is 4 and 2 times itself is 4. Then I have 5, which is an odd number, 1 and itself, that means it's prime. 6 has 1, 2, 3, and 6, meaning it is composite. Now, this really does not have anything to do whether it is even or whether it is odd, because notice that 2 is an even number, yet it's prime. 3 is an odd number, 5 is an odd number, both are prime, but then when you start getting to 9 and 15, even let's say 21, all of those numbers are odd, yet they are still composite because I can think of multiples besides 1 times itself that equal to that number, such as 3 times 5 is 15. It definitely has more than 2 factors, which means it would be a composite number. However, what I can generalize is that all of my prime numbers, all of the prime numbers will be odd except for 2. That does not mean that every odd number is prime. So hear me out. Not every odd number is prime, but all the prime numbers are odd except for 2. Every other even number besides 2 will be composite because all the even numbers can be multiplied by 2 and 1. So besides 2, every other even number is composite, guaranteed. So we're going to look at example 1. It says the first 3 prime numbers are 1, 2, and 5, given to you on the table. What are the next 3 prime numbers? So go ahead and start after 5, 6, we know is composite. Then let's think 7. Well, the only multiplication facts I can think of that equals 7 is 1 times 7, which means it has only 2 factors. 7 is our next prime number. After 7, 8. 8 is not a prime number. I can do 2 times 4, 1 times 8. That's composite. 9. I can do 3 times 3 and 1 times 9. Therefore, it is not prime. It is composite because I have more than 2 factors. 10 is an even number. I can do 2 times 5 and 1 times 10, so it's composite. 11, I can only do 1 times 11. So 11 is my next prime number. After 11 is 12. 12 is definitely not prime. I can do 6 times 2 and 3 times 4. And 13, I can only do 1 times 13. So 13 would be my next prime number. So notice my thought process. I just went through all of these. And if I thought of multiplication facts off the top of my head, besides 1 times itself, that means it's composite. All right, now the next part that we have in our lesson goes over a term called an array. And I would like you to write this definition down as well because we don't have any practice problems. So we're just focusing on these definitions and what they are, and we'll do more practice in class, so the practice set together. So an array is a rectangular arrangement of numbers or objects in rows and columns. So the best time that these are usually very helpful is whenever, noticing at least with prime and composite numbers, if I can organize in a rectangle or square, if I can organize a number with either X's, whether they're circles, whether they're boxes, if I can organize them in more than one way and create a rectangle, then I know it's going to be a composite number. If there's only one way I can sort it, by doing 1 and the number itself, then it is going to be prime. So these are types of deals like if you hear with maybe the size of pictures or maybe the size of a picture frame or even a piece of wood, hearing 2 by 4 or 4 by 6 or a 6 by 8. All of those dimensions are usually the length and width of a given rectangle. So same thing here. I have a 4 by 3. I have 4 rows and I have 3 columns. So I have a 4 by 3, which because 4 times 3 is 12, so I have 12 X's in this rectangle. I can also do a 6 by 2 or 2 by 6, because I have 6 columns and 2 rows, or 2 columns and 6 rows. And I can also do 12 by 1, which is basically 12 X's going straight up and down. So that is what we call an array. We won't be seeing those too much, but it is, so it's nothing to really worry about. I would definitely say you won't see it very often in your book, but it is good to be familiar with because we will see it briefly. So thank you very much for paying attention. I'll be grading you on your notes in class for participation. Thank you.